Hello everybody, I'm Nick, and in this video I'm going to show you how you can make your tests up to 5 or 6 times faster extremely easily by fixing one thing. And we're going to focus on unit tests here because what you're going to see has to do with mocking. So mocking has basically tons of libraries. My personal favorite is N-Substitute, but many people use mock-q or fake it easy or a bunch of other ones. But they all have one small issue. They're heavily proxy reflection based, and that has an impact on performance. Now, in the world of AI, most tests, if not all tests, are written with AI. And you can write pretty good tests with AI if you check what the AI is doing. So you might think I can just add a bunch of tests, many more than ever actually, and be covered in all bases. And that is true, you can get there, but the problem is the more tests you have, the slower everything will run because your CI/CD pipeline will need to run them, you need to run them as part of your workflow, the AI as it builds the code needs to run them. So everything will slow down. So how can we optimize and improve it? Well, I have a new library for you called Imposter, which fixes one of the biggest issues, which is this reflection functionality or reflection speed issue. Now, as always, if you like what you see, this is an open source free library, so check a link in the description, give it a star on GitHub. It really helps these developers keep being motivated and work more on the library. But let me show you what I have here. I have a simple application with just an interface called iCalculator to sort of imitate something that we'd want to mock. Now, normally you wouldn't mock the calculator. The calculator is part of the functionality of your app. However, for the purposes of the video, I want to keep it easy for everyone to understand, so we're going to use a calculator. Normally, you'd mock things like file system calls, network calls, API calls, which can all be network calls, but you get the idea. Things on your downstream dependencies that you don't really want to test as part of your core logic that you're trying to validate. So we have this. Now, if I go to tests over here, I've already created a test project using XUnit with an arrange act as site structure. Now, normally what you'd have is your arrange where you define all your maybe mock-q rules that say that when this method is called with this value and this value, then it's expected to return this value. And here we're testing add, so we're just going to set up add. However, we're not going to use mock-q or N-Substitute, we're going to use Imposter. So we're going to, not Imposter API, Imposter. So you're going to go ahead and install that. And I'm going to show you how extremely easy it is to set it up. First, what you need to do for this setup to work is you need to define what you want to create an imposter or a mock for. So in a class called whatever you want it to be, you have to have an assembly level attribute. In this case, we're going to say assembly and then generate imposter, which is the attribute we want to apply, and then type of iCalculator because that's what we want to create the imposter for. And if I go in the implementation for this now, as you can see, we have source generation for that imposter, that functionality. So there's no reflection. All of that is done on build time, on compile time, which is great for performance. This also allows optimization, not only on speed, but also memory. And we're going to see the impact it's going to have. Now, it's extremely easy to use. I love the design of this library in terms of how it's set up. First, you would have your imposter. So we're going to say that we have the iCalculator, which is the interface you want to make an imposter for. And you want to say imposter, that defines the imposter. And then if you want to get an instance of it, like your system under test, you would say imposter.add, and then we can define what we want to set up. Now, if you watched any of my previous videos on testing, especially from years ago, you know how this works. If you want to go really in depth on this, we actually have a unit test course on DOM-Train and 110 others, including 10 brand new hands-on courses on TypeScript, JavaScript, Go, Python, even Java. That one is really actually cool. It's 30 hours long. So link in the description, use code hands-on30 at checkout to get 30% off anything. And we brought back lifetime sales. It goes away soon, but if you want to grab a course and keep it for yours forever, link in the description, give it a go. So here we have the arguments. Now, normally, if this is a reference type, similar to how it would work on mock, you would have to say that this is an integer argument, and if it is of a specific value, let's say 2, then I want to set it up. And then if you have another one here, so let's say argument 1, you would say that this then returns 3. And you can also say things like, oh, if the first one is any argument, if you used any mocking library ever, you would know how this works. If not, the documentation is pretty decent on how this works. Now, by doing this setup, and actually I made a small mistake, this is not the SUT, this is just the setup. The SUT, the system under test, would be imposter.instance. So this will give you now, if I change this to the concrete type, the I calculator you want to test. So you take that, you would say var result equals SUT, and then add, and what do we want to add? We want to add 2 and 3, or 2 and 1 to make sure it's 3. So I'm going to say, without a library, assert 3 is the result. So these two are equal. A very important thing to note though, because we're working with integers, those are value types, not reference types. So they're not passed by reference, they're passed by value. This means you don't actually need this arg thing. Value types, because they are copied, they can actually make our test be a bit cleaner because you don't need to define them in the args way because of how they work behind the scenes. So if you know what's a value type and what's a reference type, again, things we cover on our courses as well, and I've talked about in a billion of my videos, then you'd be able to recognize what is what, and it would work. Exception, however, is strings. Strings are reference types, but they're passed by value. Whatever. This now means I can go ahead and run this code, and as you can see, the test will pass. If I stick a breakpoint here just to show you how this is being debugged and how this works, I'm going to step over here, ignore the compilation error, it is false, and you can see that an imposter has been created with a bunch of things inside of it which allows the wiring to work, things like history collection if you want to grab invocation, so if you want to check that the method has been called without actually that method returning something, then you can use that functionality from Imposter to validate it. Then you get the SUT, it is that concrete implementation instance, and you can see inside here, it will make it in compile time, and then you're going to get the result, and the result is 3. You can even say that first it returns 3, and then it throws, or then it returns 4. You wouldn't do it here, but you can. So it allows also chained method invocation if you want to show some side effects or some changing in behavior as you go. Extremely simple, extremely easy, pretty clean implementation. I really like it. But what's the performance like? Well, let me show you. What I have here is a bunch of benchmarks. I have my setup as before, and I have benchmark.net to run them. And the benchmarks are the exact same example. So we're setting up Imposter here, SUT, and then return the method, and then mock with the setup the same way you would do it in mock, get the object, and then return the result. So all I'm going to do is make sure this is in release mode, and it is, and I'm going to say go ahead and run this benchmark, and let's see what we get back. All right, so results are back, and as you can see over here, where is it? Here we go. Imposter, 226 nanoseconds and 2.85 kilobytes of memory allocated for the execution. Mock, 1.389 nanoseconds and almost double the memory, or a bit under double the memory. So not only is it 6 times faster, it is also half the memory, speeding up the entire process of running a billion tests. So extremely, extremely efficient. And again, this is the absolute simplest situation. The more complicated your setup, the faster this approach will be, as opposed to something like MOQ with chained mocking and setup and everything that you need to do. So what you see here is the absolute minimum increase you should expect. This increase should scale with more invocations, way more, and significantly increase the gap between the two if your mocking setup is more complicated, which usually it would be. More objects, reference types, more complicated things. So I really like what I see. I really want this project to succeed and have more implementation and more features. So link in the description, give it a like if you wanted. And now I want to know from you, what do you think about this? And are you using something else that is doing something similar? Leave a comment down below and let me know. Well, that's all I have for you for this video. Thank you very much for watching, and as always, keep coding.